So data check the throughput first. Up to now, you can think. We have Aloha, study Aloha, so ignore. And we have auto try. So we have case P equal to 1. And this auto try better than study Aloha. Better than study Aloha. But auto try, we have a more collision. This one not good. Not good, then we can reduce the probability to a half. And this better. And we can to 0.1, even better. And we can to 0.01, even better. But look at this. If we have a trend, if we load this one, even better. If we approach 0, in fact, we don't have that case to 0. So we have a different story for non-persistent. So non-persistent here, it is not identical to the P persistent CSMA with the P equal to 0. No, that case, and it is not that case at all. Non-persistent, actually, we should have a different design. The different design here, it says, okay, even we have a non-persistent, maybe better than some CSMA, P persistent CSMA, but maybe not better than P persistent with the P lower. So this is a current graph. Non-persistent, not derived directly from P equal to 0 because not workable for that case. However, P persistent, actually we can set P to a really small value, for example, 0.01. Look at this, the current version, 0.01, even better than non-persistent. So it doesn't mean a non-persistent with the P equal to 0. No, it's a different story. So that's why I mentioned these. And furthermore, maybe you have a question, why? Probability equal to 0.01. In fact, for CSMA current derivation, we based on the assumption, many stations want to try. So we have the existence of many stations want to try. Based on this, and then even 0.01, we can have performance higher than the others. It even says, okay, if we can have a probability to an even lower value, then the performance will be even higher. Under the assumption, many attempts, that says, possibly we can have infinite station want to try. For that case, then we can have the current trend. Or otherwise, think about this. Okay, for CSMA, but we consider finite attempts from finite number of stations. Then it says, okay, we just consider 10. If we have 10 and right now 0.01, actually sometimes indeed it's okay for you to try. But if we have a finite station, then sometimes we have an idle time there. So we waste the utilization of the channel. So let me know this again. The current assumption we mentioned, we have a lot of stations want to try. Even we have the infinite number of stations want to try. So that's why probability equal to 0.01, we still have the beta throughput. So here, P equal to 0, actually really small version, not 0, because 0, it won't be a feasible solution. So we need to have the different design for the case if we have P equal to 0. If you want to map 0, then we have non-persistent. So in fact, non-persistent is a different story, not derived from P equal to 0 in the series of P persistent CSMA. So we should have a different story, the story here. This one, actually, it's the working mechanism for non-persistent. So think about this again. We start from P persistent, given probability P. And the ideal case, it says, oh, okay, non-persistent, we don't want to try. So it should be the case when P equal to 0. But no, we have the different version here, non-persistent. So that's why I didn't know non-persistent explicitly here. We have idle time, send it immediately. And also that you know, oh, send it immediately. So we have the behavior, same as the case, P equal to 1. So same as the case equal to 1. So that says, should we have the version P persistent with P equal to 0? No, right? So no, this is a different version. However, if it's busy, then we wait a random amount of time. Random time, repeat this one. So when we have chance for non-persistent, it says the auto try, unless the medium is busy. So we have a random time. The random time equals random backhaul. A random backhaul try to avoid the collision. So for the non-persistent, we auto try if the channel or the medium is idle. But if it is busy, then we will have a random time. And then retry. Alright, so for the version, of course, different from the version of a P persistent with an extremely low version. Because extremely low version, oh, you ask me to try? No. Allow the other to have a chance. Others say, okay, but at this lower probability, it doesn't mean no one wants to try, right? If we have a probability 0.01, I don't want to try, but at least I still have a chance to try. And how about 0? 0 means no one wants to try. So of course, not feasible version. So that's why if it's not a case P equal to 0, then we have non-persistent. And in fact, for non-persistent, we have a new version. The new version actually don't follow the concept of P persistent because we have 0, no. We have busy, we have idle, then we auto try. So auto try, this one, in fact, not so good if we have the assumption many stations want to try. All right, so this is a real version. If we have the real version, we can get back to this. In fact, non-persistent not coming from P equal to 0, P persistent. So we have the newly defined version for non-persistent. However, look at this. Because idle then auto try, so it's possible to have a collision. And maybe more collision than the case with the P equal to a really small value. For example, here, 0.01. So that's why we have the trend for CSMA series and non-persistent CSMA. If we have a P persistent MA series, P really low and then even better. So in fact, how about 0.0001, maybe even better. But for non-persistent, no. Get worse. And because of auto try, if the medium or channel is idle. And maybe think about this. In fact, we can have the possible slow to reach the maximum value. So time maybe lower, but finally will reach the highest level for P persistent if P is really small. All right, so this is the possible phenomenon achieved by different versions of CSMA series. About all of the versions here, any questions? No, right? So finally, if I ask you the current design non-persistent coming from P equal to 0, No. Right? No. Totally no. It comes from a different idea, different version. This version. All right. So we can have the study one. Actually, because last time, so we can have the study one. In fact, we can have an unstudied one. For both study one and unstudied one, actually, you can find from some papers in the literature. Then we can have the performance. And so that we can have the graph for the previous figure. But it's somehow hard, so I ignore the further derivation for the extended version, CSMA, P persistent, non-persistent. But you can check the results in the task book. And also you can refer to the task book and check in the possible reference so that you can find the source to know how to have the derivation. All right. So the derivation is somewhat complicated. If you are interested in the derivation, sure, you can find the paper and know how to have the results. All right, that's all. So this is the discussion for the random access protocol, specifically starting from Slotty Aloha to the current one, CSMA. And for CSMA series, actually, we don't check the detailed derivation, but at least checking the Slotty Aloha and Pure Aloha, you should understand some idea. So some idea, Slotty version better or unslotty version better. At least Slotty version better. Why Slotty version better? Because we can have some coordination, right? Coordination first, and also regulation. Regulation says, okay, I have the regulated slots. Oh, we don't have the regulated slot. Which one better? For collision, consider collision, of course. The slotty version will be better because of the good regulation. So even slotty version, we can have the better version. All right, that's all. So before you go, let me measure any questions. If no, let's call your day and see you next week. And as for the team to find any project topic, I think at least just follow the activity in this this Monday. And maybe you want to change. Oh, okay, you want to find the new partner, sure. But follow the previous idea to continue. And so that you will have your own topic and your own team to have the final project, to have the final report, to have the final oral presentation. As for some possible hint to achieve good scores, you can try to check the syllabus. And we have the rubrics, how to have the evaluation for the oral presentation and the evaluation for the final report. So you can check the syllabus. All right, that's all. So any questions? If no, see you next week. Bye-bye.